Hi guys, I'm just going to quickly run through the difference between cis-trans isomerism and EZ isomerism. And the main thing is, especially at A-level, I never really understood the difference because I was never taught it, never explicitly explained it, but now I'm going to try and help you guys understand it. If you look at cis-trans, well, I'll explain EZ in a minute, but if you look at these carbons, they're bonded to two different groups. This is a different group to this. This is a methyl group, and this is just an H. And so that ticks a box. You need two different groups on one carbon. This one, it also has a different group. This has an ether and this has a hydrogen. You look at them separately, by the way. So that has two different groups and that has two different groups as well. And so that ticks both the boxes. The other box it needs to tick in order to be cis-trans is it needs to share a common group between the two carbons, like so. And if it shares it, then you look at which group is the highest priority. So as you can see, this will be the methyl group is higher than an H, and the ethyl group is higher than an H. And so it's trans because it's opposite. It's not on the same side, they're opposite, they're trans. This, exact same logic, two different groups. They share the same group between the two carbons, and therefore, if you look at it here, it's cis, it's on the same side. And so that covers what makes it cis or trans. With EZ isomerism, it's a little bit different. You use CIP rules, which stand for Kahn Ingold Prelog. You won't need to remember the name, you might need to remember CIP, but if you look at it, it's just alphabetical, because that's the reason they put their names in order. It was just Kahn Ingold Prelog, 3 people who made the rules. And all it is it states that the higher priority group on the carbon is the one with the highest atomic number. So it's got the most protons in it. But the one thing that I was on about here is it has to have two different groups. But the other thing it has to have is it has to not share a group between the two carbons. So obviously the H is the lower here, and the Cl is the higher priority. But on this side, there isn't an H and there isn't a Cl. If this was a Cl, for example, you could do cis-trans. However, there are no similarities. Same with this one, because these are just EZ isomers. These two are different to these two. There is no similarity here. And so that is the reason why it's EZ. E is opposite. Comes from the German word entgegen, which just means opposite. This is the higher priority group, Cl. This is also higher priority. Br is higher than F. And this one, Z, zusammen, a good like mnemonic is to say same side. So it's the same side here as the double bond. Same means the same way. Not these two, but these two, pointing the same way. Hopefully that helps.